And our next speaker is Kelly Loggenberg. She's going to be talking about genetic testing. Kelly is a genetic counselor with more than 15 years experience. She is the in-house genetic counselor at Next Biosciences and also works in private practice. For the last 5 years, she has focused mainly on reproductive genetics.
Right, good afternoon, everyone. Thank you so much for the introduction. So what I'm hoping to discuss this afternoon is just to talk you through some of the genetic tests that you may come across as part of your fertility journey. So certainly I won't be able to cover everything, but just to give you some context and background, I'm going to recap a little bit of genetics just to give you some perspective, and then I'll mention each of the tests briefly. My hope is that when you leave here today, that some of these names will be familiar to you so that if it comes up in discussions with your fertility doctor, you'll know where to go and get some more information about them. So that would be from your genetic counselor. So we'll go through, as I mentioned, just a brief recap, the genetic tests, and then I'll talk a little about genetic counseling. So as a reminder, we are made up of millions and millions of cells, and in each and every cell of our body, in the nucleus, we find our chromosomes. So our chromosomes really are the blueprint of life, and on our chromosomes we find our DNA, which makes up our genes, and our genes determine everything about us, so how tall you are, how different parts of your body function. So the tests that I'll be talking about today, some of the tests will be focused on chromosome testing, and some will be looking at DNA testing or testing for single gene disorders. Okay, so this is a recap of biology. So you will remember that we have 46 chromosomes in most of the cells of our body. They come in pairs which are numbered from 1 through to 22, and then the last pair determine your genetic sex, with males having an X and a Y chromosome and females having 2 X chromosomes. So we get 1 chromosome of each pair from each parent, and if there is any extra or missing chromosome material, we know that that can lead to problems with the development either of an embryo or a pregnancy. And we call that extra or missing chromosome material when there is an abnormality an aneuploidy. So that's a word that you may come across. So just some examples of chromosome abnormalities. So you could have a missing copy of a chromosome. So here I've circled chromosome 4. Or you could have an extra copy of a chromosome. So typically, when we have missing copies of chromosomes, that embryo or pregnancy wouldn't be viable. But some chromosome conditions can lead to the birth of a child with a specific genetic condition. Right, so if we unravel our chromosomes, we get to our genes, and we have more than 20,000 different genes spread out across our chromosomes. So that's a huge amount of genes with lots of different functions that determine everything about us. And for all of those genes, for most of them, you have 2 copies, one that you get from each parent on the different copies of the chromosomes that I mentioned on the previous slide. So I briefly want to touch on 2 kinds of inheritance, which will become clear in some of the tests that I mentioned. So in some cases, for you to have a genetic condition, you have to have 2 faulty copies of the same gene, one from each parent. And it's only if you have 2 faulty copies that you will present with the condition in question. So some examples of a recessive genetic condition would be things like sickle cell disease, cystic fibrosis, and there are a number of other recessive genetic conditions. Dominant inheritance we're not really going to touch on today, but that's where you only need 1 faulty copy of a gene to have the condition in question. So you inherit it from one of your parents, who may know that they've got the condition. So for example, a predisposition to certain kinds of cancer. Okay. So the first genetic test that I wanted to mention that you may come across as part of your fertility journey is preconception carrier screening. So this is a test that is done for healthy individuals and healthy couples who would like to clarify the risk of specific genetic conditions in future children. So what we would do is we do a test where we would screen for these recessive conditions that I mentioned. So we all, on average, are carriers of between 3 and 5 recessive genetic conditions. Most of us don't know that. We don't know what we are carriers of because it doesn't cause us any health concerns. Because you only have 1 faulty copy of the gene, you have another that compensates for that one, so you would never know. But when two individuals who are both carriers of the same recessive genetic condition want to start a family or have children, there is a risk to their future children of inheriting both faulty copies. So that's essentially what we are trying to screen for with preconception carrier screening, is these recessive genetic conditions to clarify the risks of having a child with one of these conditions. So it's only if both partners are carriers of the same condition that there is a risk. And the chance of that, so when we look at sort of big studies that have done these kind of tests, in about 2% of cases, you will find, when we do this kind of testing, you will find that a couple, both partners may be carriers of the same condition. However, there are some caveats to that. So in certain population groups, there may be a higher risk of specific recessive genetic conditions. If there is a known family history in one partner's family of having a recessive condition, obviously we would need to look specifically at that. And then also in some cases where a couple is considering using either an egg or a sperm donor, it may also be a test that they want to consider both for the recipient partner as well as the donor to make sure that they're not carriers of the same genetic condition. Okay. Right. So male infertility, I'm not going to spend too much time on this because there's a whole talk dedicated to this, and Dr. Mayoto is going to be talking, I think, just after this about male infertility. But there are a number of tests that come up in this specific situation that could be considered and that your fertility doctor may raise. And typically they are looking at chromosome testing. So where we are looking for chromosome abnormalities specifically linked to the sex chromosome. So remember the X and Y chromosome. Y chromosome microdeletions is when there are very small pieces of the Y chromosome that are missing that we would be looking for. And then a very specific genetic condition, which is cystic fibrosis, may also be relevant in cases of male infertility. Okay. Right, so the next group of tests, so this is really a group of tests that we would be looking at, is called pre-implantation genetic testing. So pre-implantation genetic testing is testing that is done on early stage embryos. So these couples that are considering PGT would go through an IVF procedure, so you would have to have IVF, and this is a test that's done alongside that on early stage embryos. So you would go through the IVF procedure, your embryos are allowed to fertilize in the clinic and develop until around day 5 or day 6, at which point an embryologist does a biopsy where they remove typically between 5 and 8 cells from the embryo, and it's those cells that are sent to the lab for testing. So your embryo remains safely at the clinic, that never leaves, it's just that biopsy of the cells that gets sent to a genetic testing laboratory to then do one of these 3 tests, and I'll talk about each of them in a second. So there's a lot of acronyms there. You'll see there's PGT-A, PGT-SR, and PGT-M, and they are all used in different circumstances. Okay. So PGT-A is the one, so pre-implantation genetic testing for aneuploidy, and if you go back to the earlier slide, aneuploidy is referring to that incorrect number of chromosomes. And this is the one that you may come across probably more often than the other 2, which I will mention. So PGT-A is a screening test that is done on embryo biopsy samples, so on those few cells that are received, to screen to check whether the embryo has any extra or missing chromosome material, or whether there are the 46 chromosomes that we would hope that there are. Because if there is any extra or missing chromosome material, that embryo is highly unlikely to lead to a viable or ongoing pregnancy. So it may be that the embryo doesn't implant, there may be an early pregnancy loss, or in some cases, depending on the chromosome abnormality, there may be a specific genetic condition. So the aim of the aim of PGT-A alongside IVF is to select an embryo with the correct amount of chromosome material to increase the chances of a healthy pregnancy. So there are many scenarios. So we know that these chromosome abnormalities that we can detect in the embryos happen across all age groups. So anybody could consider PGT-A, but we do know that there is an increased risk of them as women get a little older. So in specific groups, your doctor may raise the possibility. So typically women, perhaps over the age of around 35, the doctor may start raising whether PGTA should be considered alongside the IVF treatment. Okay. So the aim really, as I said, is to allow your fertility doctor to be able to selectively transfer an embryo with the correct number of chromosomes so that there can then be hopefully a healthy ongoing pregnancy. It is important to remember that these tests all have limitations. They can't guarantee the birth of a healthy baby or a healthy pregnancy. There is no one test that can do that, but it can give you a lot of information about the embryo that is being transferred. PGTA is looking for chromosome problems. It is not telling us about specific genetic conditions, so like cystic fibrosis or sickle cell disease. Okay. So PGTSR, so pre-implantation genetic testing for structural rearrangements, it's a bit of a mouthful, but this is a very specific test for a small group of individuals who are known to carry a balanced chromosome translocation. So the couple may know that one partner carries a chromosome rearrangement. So what that is usually where two chromosomes have each broken off a piece and swapped places. So all the chromosome material is there in the individual that carries the translocation, but when there is a pregnancy, there's a higher chance of passing on an unbalanced amount of genetic material. So PGTSR is the same test essentially that's being run as PGTA because we're still looking for chromosome abnormalities, extra or missing chromosome material. But here we may know that one partner is carrying a translocation between chromosome 3 and 6, and that's important information for the genetic testing laboratory to be aware of, so that they can specifically look at those chromosomes and make sure that if there's anything extra or missing there, they can detect that. Okay. And then pre-implantation genetic testing for a monogenic disorder. So this is where we get really, really specific, where we are testing for a specific genetic condition that's known to be in the family. So this would typically be where either one partner in the couple is known to have a genetic condition and they want to prevent passing on that condition to their children, or if a couple have perhaps had carrier screening and they know that they are both carriers of the same recessive genetic condition, they want to do this kind of test to screen and test the embryos for that specific condition that they are both known to be carriers of. So PGTM is a little more complex than PGTA and PGTSR because there is a workup that needs to be done even before you start your IVF process. Because for every couple that's having PGTM, a unique test is built based on the specific mutation that they are known to carry. Whether it's one partner or both who are recessive carriers of a condition, that workup or test design needs to be done before they start the IVF process and we can screen the embryos to test for that specific condition. So the reason why you may want to consider that is because you're wanting to reduce the risk of passing on this specific condition, whether it be sickle cell disease or a predisposition to certain kinds of cancer. But important to remember that it's not screening for all genetic conditions. It can't tell us about anything else other than the condition that's known to be in the family. Many couples will choose to do PGTA, so screening for chromosome problems alongside this to reduce the risks as much as possible. Okay. And then the last genetic test that I just want to mention is a genetic test that we can do following an early pregnancy loss. So Mandy has spoken about this. I think it's come up in a number of talks, and this is probably one of the tests where I think there is the most value in trying to understand why a pregnancy loss may have occurred. So we know that in about half of early pregnancy losses, so in 50%, it could be due to a chromosome abnormality that may have happened. The largest proportion of these chromosome abnormalities are random, sporadic events. But having that information about why a loss may have occurred is really valuable information for some couples who've been through that experience. It also helps with reproductive counseling for future pregnancies. So if you know that a loss has been due to a sporadic random chromosome event, in a future pregnancy, we know the risk of experiencing another pregnancy loss is not significantly increased. So it can help us, it can also help your doctor to guide further investigations, because if we know it's not due to a chromosome abnormality, they can then tailor their investigations to look for other potential causes of pregnancy losses. So this test really provides really valuable information for people that have been through that experience. We do know that there is this link, as I mentioned, with maternal age and chromosome abnormalities. So often there, this test will also be suggested to see if it was due to a random event that happened in either the egg or the sperm cell. Okay. Right, so as a genetic counsellor, I can never do a talk without just giving a little bit of information about what it is that we do. So we are healthcare professionals who have training in genetics and counselling skills. And all of these tests that I mentioned, they probably seem a little bit overwhelming. They may be the first time you've heard of them. And our role as genetic counsellors is to help you make sense of these tests, to guide you through this process, to explain the benefits, the limitations of the test, what can each of these tests tell you, but then also to advise on the appropriate testing for your fertility journey. And once there are results from testing, what do those results mean for you, for your journey, and what are your options going forward? So it really is, if you are considering any of those tests, advisable to speak with a genetic counsellor. We try to aid in informed decision-making, so to make sure that you're making the right decision for you, that you have all the information you need to be able to do that you understand the possible results and implications, and importantly, that you have realistic expectations from what these tests can tell you. So in the context of fertility, who would benefit from seeing a genetic counsellor? So in my view, there's always a role for a genetic counsellor, but I think if you are considering any of the tests that I mentioned, it would be an idea to speak to a genetic counsellor either before or after, or both, but particularly if you have results from these tests that you would like somebody to help you unpack and to see what it means for you and your journey going forward, it would certainly be worth speaking to a genetic counsellor. So there are many genetic counsellors in South Africa, and we can certainly put you in touch with somebody, should that be something that you are interested in. Okay, so I'm going to end my talk there, and I'm happy to take any questions, but I'm also here for the rest of the afternoon, so you're welcome to come and have a chat at our stand at the back. Okay, thank you very much.
Has anybody got any questions for? Yep. Here we go.
Good afternoon.
Hi.
I just wanted to find out, are you guys able to have like an artificial influence on the genetics when you discover that there's either something lacking, or are you also able to influence like things like gender of the embryo before?
So unfortunately not. So we can't. Technology is not quite yet at the stage where we can manipulate the genetics. What we can do is we can tell you what we see. So we can give you information about the embryo, which may then help your doctor to select an embryo that is better suited for transfer. But we can't fix, if we find a problem or an abnormality, we can't fix that yet. So both for the chromosome conditions that I mentioned and the single gene disorders, we can tell you whether it is present or not, to allow your doctor to select an embryo that's perhaps unaffected, but we can't fix the problem yet.
Okay, last question. In cases of using a surrogate, and you find that the embryo is fine genetically, but the carrier might have genetic, what are the chances of the carrier influencing the embryo?
So if the surrogate is a carrier of a genetic condition,
Yes.
that wouldn't have an impact on the embryo or the pregnancy necessarily. Okay.
Any other questions for Kelly? She will be at the next Biosciences
Stand,
stand, which is the beautiful one down on the left-hand side.
Yeah.
And you're going to be here.
I'm here for the rest of the day.
She's here for the rest of the day. So if you
There you
guys
go.
can think of any other questions between now and then, feel free to stop by the next stand and chat to Kelly.
Also,
Okay.
if you just want to know what genetic counsellors do, come and chat to me.
Yes, it's such an interesting. If I had my life over again,
Okay.
I would be a genetic counselor. Thank you, Kelly.
Thank you so much.
Thank you.